Our project topic is applying machine learning to New York City data, and this is by Ghio, myself, Preston, Rakovsky, and Daniel Wang. In today's world, a significant amount of employers are looking for specific skills for positions that many candidates just don't have. Likewise, many job candidates just aren't clear on what some specific titles mean or how exactly that's going to translate into their pay. In this project, we applied multiple linear regression algorithms on a public government dataset that combined hundreds of positions with vastly different titles and requirements. We searched for patterns from what different jobs were looking for and what these positions, titles, and levels were willing to pay each individual. But you might be asking yourself if this problem really is significant, and I'd argue that, of course, now more than ever with the new coronavirus pandemic spreading, this problem is greater than ever before. As of just this month alone, 22 million Americans have registered as unemployed, and in New York State, an estimated 1.2 million individuals are currently filing for unemployment because of this crisis. So the main question that we came up with essentially boiled down to how do the features like agency, posting type, and title impact wages on New York City employment, and which features will be most important for making the various regression algorithms as accurate as possible. And from this, we derived the hypothesis that titles that include the word executive or director will pay more on average than positions without, and jobs that require a higher level of education will in turn have higher wages. The New York City data that we used encompassed all of the public agencies that New York had to offer, which is around 50, and is responsible for the 306,000 full-time employees on their payroll. The average total pay was found to be $85,636, but for only civilian employees, the average total pay was $73,106.
Our dataset was obtained from the online database Data World. Important variables included things such as the agency, the qualification requirements, the business title, and the salary range given as a salary minimum and a salary maximum. Our independent or feature variables included title, the level of education, the agency, and the posting type, while our dependent variables or the target variables included the salary, which was given as the average of the salary range. This was a regression model. This was supervised machine learning, and we used algorithms such as linear regression, lasso, ridge, k-neighbors regressor, and linear SVR. We had some difficulties with data wrangling due to the complex nature of the dataset, but we were able to transform qualitative variables into useful quantitative ones using methods such as one-hot encoding. We produced data visualizations such as the ones below, which shows a relationship between the average wage of highest paying position and the average wage of all positions for each agency, where each circle is one agency. Furthermore, we have a distribution of the different postings amongst the different New York agencies. As you can see, the most is 22.4% in the Department of Health and Mental Hygiene. These are two important data visualizations. These show the relationship between the salary cap, which is the salary max, and the agencies or the job titles. As you can see, there isn't much of a strong correlation, as the results are generally pretty widespread for both graphs. Although we do notice that most positions, the average is towards the bottom, with a few outliers towards the top. For constructing, optimizing, and testing this dataset, we split the dataset into a training, validation, and testing sets. We built the model and then evaluated it using the validation set. Then we hypertuned the parameters using methods such as min-max scalar, recursive feature elimination, and grid search CV. We noticed that even that testing the data set afterwards, that there was poor underfitting and overfitting on many of the models, even after hypertuning the parameters. But we did realize that the best results came with the ridge regression and min-max scalar, as the R-squared values were the closest without overfitting.
For hypothesis testing, we first checked whether the assumptions of normality were met, which they were not, so we used non-parametric tests. To see whether the presence of bachelor's or master's and the minimum qualifications indicated anything regarding the salary, we used the Man-Whitney-U test. Additionally, to see whether different titles paid differently or positions at different agencies paid differently, we used the Kruskal-Wallis test. It was clear that if bachelor's or master's were present in the minimum qualifications, then that position did pay significantly higher, as seen by the p-values and the average salaries. Additionally, positions with different titles did pay differently, and positions at different agencies did pay significantly differently. Moving on to machine learning, the best results occurred when we used ridge regression and min-max scalar, which avoided underfitting the model like many of the other algorithms that we utilized, which had R-squared training values that were significantly less than the R-squared testing values. This is most likely due to the fact that many of the factors were interconnected, the sample size was somewhat limited, and there were a significant number of outliers that skewed the data. Some takeaways in future work: we did verify a lot of our initial hypotheses, that titles for positions and minimum qualifications do in fact relate to salary, in addition to the agency that you work for does influence how you are paid. The regression models that we utilized were not very accurate in predicting the salary given the job posting data. Some next steps are that we could perform follow-up tests to identify the position titles and agencies that pay more. We can examine job postings in other U.S. cities and other countries, and we can also expand to include private companies. Thank you very much. Please let us know if you have any questions.